actually fairly similar to yesterday's webinar. In this webinar, we're going to prove that to answer challenging questions in number properties, you need to you don't just need to know the concepts, but you need to know how to apply those concepts as well. And to prove my point, what I'm going to do is I'm going to focus on just one very simple concept, which is the concept of remainders. And pretty much everyone over here probably knows how that particular concept. And using that concept, we're going to apply that concept to solve the most challenging questions that the test will throw at you. Now, unlike yesterday, when we solved like 4 difficult questions, primarily using the meaning-based approach in SC, using very little grammar, today we're going to solve 3 very hard questions. But in addition to that, we'll also solve about 10 additional questions, starting from the very basics. But the core part is going to be very similar, where we're going to prove, yes, you need to know the concept, but once you know the concept, there are certain good habits that you need to inculcate. And once you inculcate those good habits, you're going to find solving challenging questions starts to become fairly easy. It's fairly application focused webinar. It's a very progressive webinar, which means we'll start with simple questions, then we'll slowly increase the difficulty levels. Now, for those of you who want to complete your knowledge in the topics that we talk about today, I'd recommend that that you actually go to the free trial, look at the concepts and primes, because that'll complete your knowledge and you're going to find a tangible difference in your number properties ability post this webinar if you go through those video lessons. I'm going to actually hide those video lessons over here. Now, we also have some upcoming free sessions. We have a free webinar on GMAT reading comprehension. If you need help getting to that 90th percentile in GMAT RC, this is the webinar for you. In this webinar, we're going to really look at 4 key reading strategies using which you will be able to ace GMAT RC in about 10 days. We also have a free webinar, a free quant workshop, which is next Sunday, a week from now. Excuse me. Think of this workshop as a proctored mock test, but a mock test that gives you probably 3x as many insights as a regular mock test does. So this proctored mock test is designed to help create your own personalized study plan. Again, you may register for that over here. With that, let's kind of get to understand this group a bit better. I'd like to know, when do you want to take your mock, when do you plan to take the test, as well as what is your target GMAT score. All right, let's get a few more responses. I'm sorry, just hold on 1 second. I think I put in the wrong portal over here. Okay, let's get a few more responses. All right, with that, with regards to the GMAT date, I'd say barring the last group, which is those who haven't taken their date as of yet, we were fairly uniform distribution. Let me actually make sure. All right, yeah, so we have 37% of people in that group, but other than that, the biggest group is about 20%, the smallest is about 10% over here. And then with regards to the target GMAT score, that 730 to 750 bucket is the biggest, about 51% of you were there. Then 760 or higher, about 13% of you. Fairly significant number of you in the 710, 720 bucket as well. And about 8% of you in the 660 to 700. All right, with that, let's go right into the webinar pane. I'm going to change the orientation of the screen, and you're going to really see a presentation come up as well as a Q&A pod at the bottom. Let's wait for another 15 seconds or so. All right, while we do that, I'm going to bring in a couple of poll questions because we're going to go and hit the ground running. All right, let's just go forward. I'm going to move to the right slides over here. So, what's the goal of this session? In this session, we're going to help you understand what is important when it comes to acing GMAT Quant. What's important when it comes to getting to that Q50, Q51 score. And yes, you need a sound understanding of the basics, but we're also going to make you realize the structured approach that you need to solve questions. Okay, so in terms of the progression of the session, we're going to solve three questions, three data sufficiency questions, which are 700 level. We're going to call them question numbers 8, 9, and 10. And we're going to just solve those questions. We're not going to discuss them in detail. Then we're going to really understand how do we build a capability to solve these three questions. The entire session is going to be about this. Okay, uh, um, and then we're going to start with some very basic questions. We're going to then increase the difficulty level over a course of 8 questions. And then once we are done with those 8 questions, then we're going to solve these 3 questions. And once we get towards the end, you're going to find that these 700 level questions would become seemingly easy or would seem easier to do. So again, as you can see, everything that I talked about over here. So we're going to start with these 3 questions and we're going to discuss them in detail. Okay. I see a bunch of you have been asking questions about how do you plan your preparation and so on and so forth. Guys, I'd be happy to answer those questions, but if you pose those questions towards the end of the session, I'd be happy to address those. But right now, we're going to learn number properties, and we're going to see how we can ace this one particular concept on divisibility and remainders. So with that, let's solve these questions. Now, for those of you who attended the webinar yesterday, you guys remember the way we go about doing this is that I don't time you. I want you to select still solving. And once 80% of you select an answer choice other than still solving, I call time. That way, as a group, you guys time yourself rather than me timing you. What's PS and DS? PS is problem solving. It's a type of question that you get on GMAT Quant. DS is data sufficiency. All right, let's get about 30 people saying still solving. 3, 2, and 1. We got about 34 people saying still solving. Let me just remove broadcast results. Here is your first question. Good. All right, guys, another 15 seconds. About 30% of you are done. Five, four, three, two, and one. Let me end the poll. I'm going to broadcast the results, and what you can really see is choice C is really popular, so is choice A. All right, let me hide this. Now we're going to go towards our next question, and you guys know the drill. Select still solving. Okay, let's get about 40 people to select still solving. All right, 39 people, 40. Okay, here's my next question. I'm going to mute. Guys, it's about time. We have another 20 odd seconds before we move on to the next question. 5, 4, 3, 2, and 1. Let me end the poll. I'm going to broadcast the results, and what we really see is choices A and C are again popular, but we also have choices D and E that are quite popular as well. So clearly there's a lot of confusion with regards to this question. We're going to really see how we address that confusion, and then let's go on to the last difficult question. And let's select still solving. Again, let's get 40 people to stay still solving. All right, we have 42 people who said still solving. And here is your question. All right, guys, get those answers in. The time's almost up. 5, 4, 3, 2, and 1. Let me end the poll. Broadcast the results. And what we see here is choice D, a clear favorite, but choices A and B are very popular as well. So again, we'll see the stats overall. So that was a lot of fun. And so our goal today is to make sure that each one of you can answer these 3 questions correctly. And what I'm going to prove to you in about another hour and 30 minutes is that if you have a basic understanding of divisibility and remainders, you can answer these questions, provided you can inculcate some good habits. So there's no complex math required, only a few good habits. And to get started on that journey, we're going to start with what we call as the warm-up section of this webinar. In this warm-up section, we're going to do some basic questions in divisibility and remainders. We're going to give you some feedback about what you currently know and where you're faltering, if at all you're faltering. And in this warm-up section, I'm going to provide some basic solutions, but not detailed discussions. The goal really is to make sure that we do we do a refresher before we move on to more challenging questions. Okay, so with that, I'm going to start with some very simple questions. They'll have 3 answer choices, and then we'll get to the answers, Mohawk, towards the end. You'll get to know. So the idea is to have fun and to make sure that you can solve these questions rather than me telling you the answers as well as me telling you the solution. Okay, so let's do still solving. Let's do about 40 people saying still solving. 5, 4, 3, 2, and 1. We got 40 people overall. Here's your first question. Let's get to the answer fairly quickly. This is a very, very basic question over here. Everyone's done over here. That's wonderful. Let me end the poll and broadcast the results. And 74% of you said it's always divisible by 3. 74% of you would be correct. As I said, this is a fairly simple question. So what's the divisibility rule of 3? The divisibility rule of 3 is that the sum of digits should be divisible by 3. So what's given to us is that z is a 3-digit number whose digits are consecutive numbers. So what's the sum of digits of z? Let's call the digits to be x plus 1 and x plus 2. Why? Because they're consecutive numbers. So sum of digits is x plus 1 plus x plus 2, or in other words 3x plus 3. Take 3 common, it's times 3 times x plus 1. It's 3 times a number, which is always and because it's 3 times a number, that product's always divisible by 3, and hence the correct answer is choice B. Okay, so fairly simple. It's how do you represent 3 consecutive numbers? Okay, let's move on to the next warm-up question. You guys know the drill. Select still solving. Again, this is just us warming up. 3, 2, and 1. Let me end the poll. And then here is the next question. All right, 80% of you are done. Let's get those answers in. 3, 2, and 1. Let me end the poll. Let me broadcast the results. So we have a split jury. Choice A is the correct answer. Choice A says z may be divisible by 4. A lot of you chose choice C, which is that z is not divisible by 4. What this indicates to me that you guys tried to take a few numbers, and yes, you figured out that many of those numbers are not divisible by 4. What you did not do, and the right way of doing this, is to make sure that A, you build some cases, and B, you apply the divisibility test for 4. And let's see how we go about doing this. Okay, so I'm going to talk about the theory over here. So what's the divisibility rule for 4? That the last 2 digits need to be divisible by 4. So if the last 2 digits are 0, 4, 1, 6, 2, 8, 3, 2, any number that has, last 2 digits that are divisible by 4 is actually divisible by 4. All right. So what this is saying is that z is a 4-digit number whose digits are consecutive numbers. which of the if that's true, then which of the following statements is true? Select the correct statement based on that information provided above. So the first thing when you think about this is you could say, hey, z could either be odd or z could be even. So if z is odd, clearly z cannot be divisible by 4. Why? Because the last two digits are not divisible by 4. 4 only divides even numbers. Okay. Then the second option is that z could be even. Okay. If z is even, then in that case, the last two digits may be divisible by 4 or the last two digits may not be divisible by 4. And how do we figure that out? If the last two digits are divisible by 4, here's an example: 3, 4, 5, 6. 5, 6 are divisible by 4. So 3, 4, 5, 6 is divisible by 4. Or the last two digits may not be divisible by 4. An example would be 1, 2, 3, 4. You see them as consecutive numbers. 34 is not divisible by 4. Hence, this number is not divisible by 4. So essentially, there is a possibility that z is divisible by 4. There's also a possibility that z may not be divisible by 4. Hence, the correct answer is choice A. So, I understand that you guys made a mistake. Tell me where in the approach or how was your approach different from mine? How was your approach different? Okay, picked random numbers, same approach. Good. If you had the same approach, that's wonderful. You misread it. All right, perfect. Okay, I don't know what beta is, but you tried the same approach, but miscalculated. And again, when you think about this, what you find is this approach is much more comprehensive. And when you and that's kind of the piece that you want to learn. There's no math in this. It's simple logic that you want to imbibe while doing this. Now let's move on to the next question over here. All right. In the next question, we're going to have 4 answer choices. I'm going to change the poll over here. Here is my next poll. Again, you guys know the drill. You have to select still solving. All right. I like the participation. Here is the next question. Most of you are done. Let's put those answers in. 5, 4, 3, 2, and 1. Let me end the poll. Now, before I broadcast the results, I want to ask you, how many of you, divided each of these 4 numbers by 8 and then selected the correct answer? Select yes if you divided each of the 4 options over here. Otherwise, select no. Okay, 5, 4, 3, 2, and 1. Let me end the poll, broadcast the results. I'm very glad only 10% of you did that, but 90% of you did not do that because that would not be the right approach. So how do we go about solving this? We look at this and say, hey, we're looking at the number closest to this particular number, this humongous number that is a multiple of 8. And we say, hey, if it has to be a multiple of 8, let's kind of figure out the divisibility test for 8. And what's the divisibility test for 8? The last 3 digits in any particular number should be divisible by 8. So we look at 897 over here because that's kind of what we have to really say. What's the number that's closest to this particular number that's a multiple of 8? So we look at 897, we divide 897 by 8, and that gives us a remainder 1. Okay, so if it gives us a remainder 1, then which is the number that's closest to this particular number that actually is divisible by 8? That's this particular number. You subtract 1 from this and you get to this particular number. Okay, let me broadcast the results, and pretty much all of you, each one of you got it right, but 76% of you chose choice C. Let's look at question number 4 right now. And with question number 4, we're actually going to kind of warm up a bit more. So I'm going to clear all answers, remove broadcast results, and you guys know the drill. So that's still solving. 5, 4, 3, 2, and 1. Good. Here is the next question. All right, guys, get those answers in. 5, 4, 3, 2, and 1. Now, in this webinar, we're going to talk about 2 specific skills that we're going to emphasize on again and again. One of them is going to be visualization. The other one is going to be applying constraints. And in this particular question, we're going to introduce the first of those 2 skills, that is visualization. So what does this question tell you? It says if, and you guys did really well on this question, by the way. So about 66% of you got this correct. So this question says if n leaves a remainder 3 when divided by 2 or 4, what is the remainder when n is actually divided by 4? So when you think about this, the concept that we're going to use is that dividend is divisor multiplied by quotient. So divisor over here is 2 or 4. Okay, and quotient, we don't know what the quotient is, plus remainder. So essentially what this means is that that when we think about what the question is asking, it's saying, hey, express n in terms of 4 times something plus a remainder. Why? Because it's asking what is the remainder when n is divided by 4. That's what it's asking. Now what's given to us? What's given to us is, and the constraint is that n has, the remainder of course has to be less than 4. What's given to us is that n, when it's divided by 2 or 4, leaves a remainder 3, which means n can be expressed as 204 times a number q, and that number has to be an integer, plus 3. That's what n is. Now let's kind of visualize this over here. This is how we visualize both the scenarios. So essentially what we do is we visualize and say, hey, it is possible to write 204 in terms of 4. Why? Because we want to really express this like this. So we write this as saying, hey, let's write 204 as q as 4 times p. Okay, so 204q is 4 times 51q. Okay, which means p is equal to 51q. So we already know n is 204 times q plus 3, where q is any number, which means n can be expressed as 4 times 51q plus 3, or in other words, the remainder that we get is 3. Why? Because this term over here is completely divisible by 4. It leaves a remainder of 0. So my correct answer is choice D, as most of you have said. Now, we're going to do one last question so that we kind of know that we know all the concepts. Select still solving. Let me broadcast results. And we're going to solidify this concept slightly more in the next warm-up question. Any downside of just using 207? JFD, in this question, not particularly, but if you don't understand this concept, as questions become more challenging, you're going to find using 207 is not going to be super helpful. You're not going to be able to use number substitution over here. So I really recommend using this approach if you're aiming for a score of Q49, Q50 or so. Okay, let's get to 40 responses, guys. I have 38 responses. So 5, 4. All right, we got 40 responses. But good question, JFD. Here is the next question. Let's get those answers in. 3, 2, and 1. Let me end the poll. Now, the nice thing about this was that, most of you who got it right very quickly. It was like as if you got the pulse of the question right away. So let's see how we approach this. Not very different from how we approached the prior question, barring one constraint. We use the same concept. Dividend is divisor times quotient plus remainder. Okay, and what's asked for us is what's the remainder when n is divided by 5, which means we need to express n as 5p plus r, where r is the remainder, and that remainder has to be less than 5. Remember, remainder always has to be less than the divisor. So what this means is choice D right away is out of question, because your remainder can never be greater than 5. So that's completely wrong. What's given to us is that n leaves a remainder of 6 when it's divided by 205. Again, we write it the same way, 205 times q plus 6. And again, as we visualize this, we say, let's write 205 in terms of 5 times something. So 205q can be written as 5 in terms of 5 times p, which means 205q is 5 times 41q, and that leaves a remainder 6. But then you ask yourself, hey, the remainder has to be less than 5. So 6 can be written as 5 times 1 plus 1. 5 times 1 doesn't leave a remainder. So your remainder is 1, which is choice A. Okay. So there's another important process skill, which is applying constraints. That's really important. And the correct answer is choice A. Now, this was warm up. This was very, very easy stuff. The reason why we did that was because we want to make sure that you know the basics. And if you made a mistake in any of these questions, then make sure you go to the free trial, you revise the recommended concepts, and not just primes 1, but essentially go through primes 2, 3 as well. And in fact, if you want to do a refresher in primes, those 3 videos will do a great job in helping you get started. When it comes to the real GMAT questions, they require much more advanced level of application, which we're going to really see moving forward or so. Now, let's start solving 650 to 700 level questions. And to do that, we're going to use our next poll over here and select still solving. Five, 4. Actually, we have a fairly good number of people. I don't need to do 5, 4 every time. So it's PS questions, and here is our next question. Good luck, guys. All right, guys, get those answers in, please. Five, 4, 3, 2, and 1. Let me end the poll. Now, before I broadcast the results, how many of you did the math over here in this question where you said, hey, let me actually just multiply 30 times 8.2 and then divide it by 15? How many of you did the math? Actually did the multiplication? All right, let's get a few more responses. The question is, how many of you did the math? All right, but half of you did do the math, which is not the approach that I would recommend over here. But 60% of you got this right. So let's see how we go about doing this question. Okay, what's given to us is A, that m is a positive integer, and then m divided by 30 is 8.2. And what the question is asking us is, what is the remainder when you actually divide m by 15. So again, the same concept that we use in the prior question is what we're going to use, that your dividend can be expressed as divisor times quotient plus remainder. Okay. Now once we have that, and what's been asked is to express m in terms of 15p, so plus r, where r has a constraint that r has to be less than 15. That's what we need to know. We want to know what this r is. Okay. So what's given to us is that m divided by 30 leads to 8.2, which means m can be expressed as 30 times 8.2, or if you split it up, m can be expressed as 30 times 8 plus 30 times 0.2. Are you guys with me over here so far? Can you understand this step? How we split 8.2 into 8 plus 0.2? All right, fairly simple. Then you visualize this and you say, hey, over here it's in terms of 15, over here it's in terms of 30. So how do we do this? We actually express 30 as 15 times 2 plus 6, and 30 times 0.2 is 6. So that's how we got 6 over here. And you say, okay, m can be expressed as 15 times a number plus 6. And we know that this doesn't leave a remainder when divided by 15, and 6 is not divisible by 15. So my remainder is 6, which makes choice C the correct answer. So this is your correct answer over here. And about 60% of the class got it right. Okay. Now, for those of you who made a mistake, where did you guys make a mistake? Let's clear these answers and figure out. Isn't this step much longer than simple division? No, Amandeep, it isn't. If for those of you who made a mistake, where did you make a mistake? Okay, the approach was wrong. Thought 8.2 was the remainder. Okay. Did not understand the question. If you didn't understand, go back, look at primes. You need to build that foundation because the questions are going to get slightly more difficult over there. Took a wrong number while calculating. No, do not do number substitution here, guys. If you do number substitution, you're going to be able to answer certain questions that are of a certain difficulty level correctly, but beyond that point, you're going to get stuck. Okay. Use the format that's given to you. Every question that we solve today would be solved using this equation. That dividend is equal to divisor times quotient plus remainder. If you can understand and truly apply this equation, you're going to find that solving the most challenging questions becomes easy. Otherwise, you're going to get some questions right now, but as we go forward, you're going to struggle to answer more complex questions. Okay. Now, we're going to get a chance to correct yourself. We're going to get a chance to improve. The next question builds upon this. So select still solving. All right, let's get a few more people to select still solving. All right, let's move forward. Here is the next question. All right, guys, get those answers in. 3, 2, and 1. Let me end the poll and broadcast the results. So I actually see two kinds of students now in this webinar. There's actually three kinds. The first kind who already knew this approach and are here just to enjoy. The second kind are those who are who are imbibing this approach right now as we practice it. And I see them solving the questions really quickly. And the third kind are the ones who are still doing the math the original way. So it's the third kind. If you've not imbibed this approach, I would challenge you to do it, because moving forward, as you use this approach, you're going to find solving becomes a lot faster, a lot easier, a lot less error prone. So again, we're going to use the same formula. Dividend is divisor times quotient plus remainder. What the question is asking us is to express m as 30p plus r, where r is the remainder. And remember the constraint that the remainder always has to be less than the divisor. Now what's given to us? What's given to us is that m can be expressed as 15 times 8.2. We follow the same approach and we say, hey, which means it can be expressed as 15 times 8 plus 15 times 0.2. This is the visualization of 8.2. And then we take this part over here, 15 times 8, and we really say this seems to be divisible by 30 because we can express it differently. We can express 8 as 4 times 2, and then 15 times 2 over here can be is 3. So overall, what happens is this becomes 30 times 4, so 15 times 2 times 4, and the remainder over here is 0, and the remainder over here is 3. So the overall remainder that we get is 3 over here. Okay, again, there's very little math that we did in this entire process. You could have pretty much done most of it in your mind if you were comfortable with this. So this makes choice C the correct answer. We're going to do one more question using the same method. So select still solving. Five, 4, 3, 2, and 1. And this next question, I want to challenge you to use this approach, because if you use this approach, you're going to find that getting to the answer starts to become easier. All right, let me remove broadcast results. Again, very similar construction, slightly different numbers. So you're going to have to use a slight modification, but essentially the same method, but you're going to have to adapt this method. So here is your last question in this particular sequence. As if after this, we're going to switch gears again. Right, it seems pretty much everyone's done. That is phenomenal. 3, 2, and 1. Let me end the poll. Now, again, choice B and choice E are really popular. And what we really see is those of you who chose choice B did not modify the things properly. Those who chose choice E got to the answer fairly quickly. So same approach. Dividend is divisor time quotient plus remainder. We have to figure out what is the remainder when m is divided by 30, which means we have to express in terms m in terms of 30p plus r, where r has to be less than 30. What's given to us is that m is equal to 15 times 9.2. All right. So what we do is we express it in this way: 15 times 9 plus 15 times 0.2. Now, you see over here it's 30, and 15 times 9 we know is not divisible by 30. So what we really say is we further break 9 into 8 plus 1. We say, hey, 15 times 8 plus 1 plus 3. 15 times 0.2 actually gets us 3 over here, which is where this 3 comes from. And so which means that it goes to 15 times 8 plus 15 times 1 plus 3, or in other words, essentially, we know that this number is divisible by 30. It doesn't leave a remainder. So the remainder is this plus this over here, which is 18. And again, you can see that you didn't have to do a whole lot of math to get the answer as choice E. Okay. And I could really see many of you started to imbibe this equation-based approach. You kind of get the sense of it, and that's really heartening for me to see over here. Now, let's kind of summarize what we've learned so far. In the first question that in each of these three questions, and these were the first three questions that we were going to do. Prior to this, everything that we did was warm up. We kind of applied this equation where dividend is divisor times quotient plus remainder. We used the skill of visualization, and using the skill, we solved questions that were progressively difficult. Okay. In the first question, we were told that m by 30 is 8.2, and we wanted to figure out the remainder if m is divided by 15. Again, we kind of split 8.2 as 8 plus 0.2. We got the remainder as 6. The second one, we reversed this. We said m divided by 15 got us 8.2. We had to figure out what's the remainder when m is divided by 30. Use this very similar method, and again got the remainder as 3. The third question, what we did was we were told that m by 15 is 9.2, and we had to figure out the remainder when m was divided by 30. Again, use a similar approach, but we split 9.2 into 8 plus 1 plus 0.2, and then we got the remainder. Essentially the same equation, slightly different application of that equation. Now, we're going to go towards 700 level questions over here. And again, still problem solving questions, but I want to make sure that you guys are 200% confident about using this equation. That is, dividend is equal to divisor times quotient plus remainder. Are you guys comfortable now while using this equation? Because we're going to use this equation again and again. All right. That is perfect. All right, we've got 32 responses. Now, we're going to talk about two things over here. We're going to talk about adding and multiplying remainders. And I'm going to tell you something that you can use, and I'm going to explain why this works as well. So first, I'm going to tell you what you can use. Now, if you get a question that says, what is the remainder when 31 plus 43 is divided by 7? And again, the answer over here is 4. You can get this answer using two steps. One is, you can really say, I'm going to add 31 plus 43, I'm going to get 74, and I'm going to divide 74 divided by 7, and I get 4 as the remainder. Or the second way that I can really do is, I'm going to divide 31 by 7, I get 3 as my remainder, and then I'm going to do 43 by 7, I get 1 as my remainder. and I'm going to add these two remainders up, and since the sum of the remainders is less than 7, the final remainder has to be 4. Now, which of these two approaches is correct? In this case, either one is correct because 31 plus 43 is not that big a number, but when numbers start to get big, the second approach is much better. If for larger numbers, sequence 2 just maybe a lot more efficient and a lot less error prone. So that's addition of remainders. That's the concept of addition of remainders. I'm going to talk about multiplication of remainders. Okay, and let's say you get the question, what is the remainder when 31 multiplied by 43 is divided by 7? The answer is 3. Let's kind of figure out how do we go about doing this. Again, you can do the first step where you can multiply these two. You multiply them and you get 1333, divide 1333 by 7, and essentially you get the remainder as 3. Now this is a long approach. This is not an approach that we recommend. The second way of doing it is you divide 31 by 7, you get the remainder as 3. You divide 43 by 7, you get the remainder as 1, and you multiply these two remainders. 3 times 1 is 3. Much more simple approach. Okay, this is what we recommend. It's much more efficient. Is this concept, as Nihal says, is this a generic concept or only for 7? It's a generic concept, Nihal, not just for 7, for any numbers in the numerator and denominator. Okay, so essentially, and I'm going to show why this works, by the way. So this is just for you to know this is how you go about doing it, but I'm also going to explain why this works, because you should know why something works. If you don't know why something works, you're not going to be as comfortable applying that. Okay, but clearly the first part, if you have sum of two numbers, then the remainders of individual numbers can be added. If you have the product of two numbers, then the remainders of the individual numbers can be multiplied. In either of the case, the constraint has to be the final remainder must be less than the divisor. Okay, so that's what we call as adding and multiplying remainders. Now, why does this work and what's the rationale behind this? Let's kind of see this. Okay, so again, the same piece, dividend is divisor times quotient plus remainder. That's the only equation that you need to know. So the same piece over here, what's the remainder when 31 plus 43 is divided by 7? And we got the answer as 4. So why does this work? Let's kind of look at this. 31 can be written as 7 times 4 plus 3. Why? Why do we write it in terms of 7 times 4? Because we're dividing it by 7. If we were dividing it by 5, we would write it as 5 times 6 plus 1. Okay, and 43 can be written as 7 times 6 plus 1. Again, we are using the same equation over here. Okay, so in that case, what starts to happen is you're going to really see this. 31 plus 43 is 7 times 4 plus 3 plus 7 times 6 plus 1. Again, as you add this in our formal equation form, you combine all the terms with 7, you combine all the terms without 7 in there, it becomes 7 times 4 plus 6 plus 3 plus 1. This term clearly does not leave a remainder when divided by 7, so the remainder is just this term over here. Okay, does that make sense? Does that make sense? And you can really see how we derive this purely from this equation. If you understand this equation, getting to that seems like a fairly simple derivation. Okay, Nishant says, can you explain this one? So Nishant, all we did was we expressed the numbers in terms of this equation. Dividend is equal to divisor times quotient plus remainder. So we had to find out 31 plus 43. We really said 31 is 7 times 4 plus 3, and 43 is 7 times 6 plus 1. So we had to figure out what's the remainder when 31 plus 43 is divided by 7. So here's 31 plus 43, and 31 is 7 times 4 plus 3, 43 is 7 times 6 plus 1. We added them up. Clearly, these two terms over here are divisible by 7, so the remainder is 3 plus 1, that is 4. Okay. Now let's see why does this work when it comes to multiplication. Okay. The question really is, what's the remainder when 31 times 43 is divided by 7? All right, and we said, hey, you could multiply the individual remainders and you'd get the answer. Okay, and again, the reason why this works is because it's essentially the same philosophy. Now, this is a bit more involved, so pay close attention. We are again expressing 31 as 7 times 4 plus 3. We express 43 as, 7 times 6 plus 1. All right, and when you multiply 31 times 43, what you're really saying is 7 times 4 plus 3 multiplied by 7 times 6 plus 1. Does everyone understand this representation? Yes, no? This is the key thing. This is the key thing. If you understand this representation, then what you know is that the only term that won't be divisible by 7 would be when you multiply 3 times 1, because every other term will have a 7 in it. So the only term that won't be divisible by 7 is when you multiply this and this. Okay, as you simplify it, you're going to get all of these terms. This is divisible by 7. This is divisible by 7. Why? Because it has a 7 in there. This is divisible by 7. And this is the only term that is not divisible by 7. This is the only term over here, which is what my remainder is. Okay. Is that clear? Now you can see why you can multiply the individual remainders. Why? Because this over here essentially is the multiplication of individual remainders. All right. So let's use this concept to solve some interesting questions now. Let's clear all answers, and I want to see broadcast results. Five, 4, 3, 2, and 1. Okay, let me end the poll or remove broadcast results. Here is your next question. 5, 4, 3, 2, and 1. Let me end the poll and broadcast the results. So, in this question, this is what I call as when you learn something um, and you get tricked by it. So when you learn something new, don't forget whatever you know about things. So what the question is asking, what's the remainder when 24 raised to power 3 and is multiplied by 38 raised to power 5, and this product is divided by 3? Essentially, if you look at this, you should have really said, man, this is very complex, but I know that the remainder is 0. Why do I really know that? Because 24 raised to the power 3 has a remainder of 0. This expression is completely divisible by 3. Okay. And even if you use the formula that we use in the prior question, product of two numbers is equivalent to the product of their remainders. The remainders of two numbers is equivalent to the product of the remainders. In this case, the remainder left by 24 is 0, and you should have chosen 0 right away. And that's where when you see a complex formula and you really say, man, this is going to be super difficult, you kind of forget the fact that on the GMAT, nothing's going to be super calculation intensive. All right. So why did you make a mistake? For those of you who did make a mistake. You added the remainders instead of multiplying. Approach. All right. We're going to deal with addition as well, but right now we're dealing with multiplication. Okay. Let's go on to the next question. Let's really apply these things and properly. So select still solving. 5, 4, 3, 2, and 1. Remove broadcast results, and let's look at this question and focus on applying the method over here. Okay, get those answers in. Pretty much everyone's done. 3, 2, and 1. Let's end the poll. I'm going to broadcast the results. Now, this is a 700 level question, but 68% of you got it right, and that's beautiful to me. So the scary expression, and the question is asking, what is the remainder when the scary expression is divided by 3? So how do we go about approaching this? We basically say, hey, this expression can be considered as 28 times 38 multiplied by 28 times 38 multiplied by 28 by times 38. So we kind of figure out the remainder of each of these terms. Okay. And once you figure out the remainder of one of these terms, the other terms would still be the same. So to answer this, we say, what's the remainder of 25 divided by 3 multiplied by 38 by 3? And we cube it. So 25 by 3 gives us a remainder of 1. 38 by 3 gives us a remainder of 2 over here. So essentially the overall 1 times 2 is 2. 2 cube is 8. So we say, hey, the remainder is 8, but then you can't have a remainder that's greater than the divisor. So you divide 8 by 3, and or you can express 8 as 3 times 2 plus 2, and you get the correct answer as 2. 68% of you did this, and that is beautiful. Now, are you getting more comfortable with this approach? Let's get a few more responses. Okay. So let's build upon it. And we're going to now make things more interesting. We're going to go to a concept of what we call as negative remainders. Okay. So what will we do in question number 4 and 5? That's what happened to my computer. Oh, it seems, let's just make sure. It seems I am stuck. Just give me 1 second. All right, perfect. We use the same formula. I mean, throughout this, throughout this entire session, we're going to use the same formula, which is dividend is divisor times quotient plus remainder. And we're going to use that as a foundation to solve the most challenging questions. And over here, what we said was, if you have sum of two numbers, their individual remainders can be added. If you have product of two numbers, their individual remainders can be multiplied. And we use that on scary looking numbers overall. Okay. Now we're going to look at a concept which we call as negative remainders. So what's the concept of negative remainders? Okay. So what we know is that the remainder has to be less than the divisor. And the second thing that we know is the remainder always has to be positive. When you think about 5 by 2, you can really say, hey, 5 by 2 has a remainder of 1, which means, why does it have a remainder of 1? Because 5 can be expressed as 2 times 2 plus 1. And then 2 times 2 is divisible by 2, so you get the remainder as 1. Now, let's kind of look at 8 divided by 3. Again, the remainder is 2. Why? Because 8 can be expressed as 3 times 2 plus 2. But then, sometimes, this plus x, the positive remainder concept may not be always applicable, may not be the best way to simplify an expression. So we apply the concept of negative remainders. So what is negative remainders? How about if we express 5 as 6 minus 1 or 2 times 3 minus 1? In that case, 2 times 3 is divisible by 2. So the remainder actually becomes minus 1. And then that's negative remainders. But we know that negative remainders are not possible. Okay. What are why? Because the remainder always has to be positive. So how do we go about solving this? What we do is we actually really add and subtract the divisor. So we express 5 as 2 times 3 minus 1, so 6 minus 1, and we add a plus 2 and subtract a minus 2. Why? Because then net we are adding 0. We subtract a plus 2, we add a plus 2 and then subtract. Hold on, guys. For some reason, my annotations are getting messed up. Now I'm getting the annotations. Sorry about that. Let me remove these. Can each one of you see that plus 2 and minus 2 over here? Can you guys see this? We added a plus 2 and then subtracted minus 2. Then we rearranged the terms, and as we rearranged the terms, what we got was 2 times 3 minus 1, then minus 1 plus 2. Now we know that this term over here is divisible by 2, so my remainder is 1. In the same way, we can do the same thing with 8 as well. We can say 3 times 3 minus 1, and then we add a 3 and subtract a 3. So we are adding a net 0. Okay. Again, we rearrange the terms, and what do we really say? Say 3 times 3 minus 3, or 3 times 3 minus 1, and then minus 1 plus 3. We know this term over here is divisible by 3, so the remainder is 2. Now, this may not be very apparent to you, but sometimes it's a lot more beneficial to actually express the remainder of the entire expression in the form of negative remainders. So let's kind of see how we go about doing this. I'm going to solve a few questions using the concept of negative remainders. So you guys know the drill. Let's look at still solving. 5, 4, 3, 2, and 1. That's great. And you're going to see the next question come your way. Here is the next question. %80 of the class is done. Let's get those answers in. 3, 2, and 1. Let me end the poll. So guys, I think I didn't make it abundantly clear, but to apply the concept of negative remainders, you have to just add the divisor to the negative remainder. You don't have to do that add and subtract. That was just to show why it works. So let's see how we go about doing this. Again, you're given this scary expression, and the scary expression is sum of two numbers. So by our prior concept, we know the remainder of a sum of two numbers is sum of their remainders. That's what we learned some time back. So we have to find the remainder of this. What we already know is the remainder of, as I said, the remainder of sum of two numbers, the sum of their remainders. So we know that 24 times 35 divided by 3 has a remainder of 0. Why? Because 24 is completely divisible by 3. Now we have to find the remainder of 17 to the power 7 divided by 3. Okay. Now how do we go about finding the remainder of this? There are two ways of doing it. One is we can do the positive remainder, or the second is we can do the negative remainder, where we can express 17 as 3 times 6 minus 1, which means the remainder is going to be minus 1 to the power 7. Why? Because the remainder of 17 by 3 is minus 1, and this has to be raised to the power 7. So it's minus 1 to the power 7, which is minus 1. Now, a remainder can't be negative, so we add plus 3 to it, and then we get the remainder as 2. That's 65% of you got this right. Now, can you see the power of applying the concept of negative remainders? Okay. All right. Can I explain this again? Let me explain this again. So what's given to us is you have to find the remainder of sum of two numbers. And what we know is the remainder of sum of two numbers is the sum of their remainders, which is the concept that we use over here. This particular number, the remainder is 0. Why is the remainder for this number 0? Why? Because 24 is completely divisible by 3. So we have to find the remainder of 17 to the power 7 by 3. Now, how do we do this? We express 17 as 3 times 6 minus 1. And 3 times 6 is completely divisible by 3. So the remainder is minus 1. And because we have 17 to the power 7 over here, we take minus 1 to the power 7. And because it's an odd power, we get minus 1. But a remainder can never be negative, so we add the divisor to it, which is what we learned from the concept of negative remainders. Harris says, is it necessary to use the concept of negative remainders? No, Harris, you don't, but you're going to find that if you don't use the concept of negative remainders, life starts to become more difficult, which is what you're going to see in the next question. So let's go about solving the next question. You guys know the drill. When should you apply positive or negative remainders? It depends on what leads to the answer more easily. So if the concept of positive remainders gets you to the answer more easily, then that's the concept that you need to apply. Otherwise, you've got to apply the concept of negative remainders. All right, let's get to a few more responses. 5, 4, 3, 2, and all right, we have let's look at our next question. In this, you're going to find applying negative remainders is a lot more easy. Right. Pretty much everyone's done, and everyone's done this correctly. That's and beautifully. 86% of you got this right. Let's see how we go about doing this. We're supposed to find the remainder of the scary looking expression and the remainder, which is when this expression is divided by 6. So we say, hey, the remainder of sum of two numbers is the sum of their individual remainders. Again, 24 is divisible by 6, so this remainder is 0. So we have to find the remainder of 17 to the power 7 divided by 6. We use the concept of negative remainders. Why? Because 5 to the power 7 is very difficult. So we say, hey, 17 can be expressed as 6 times 3 minus 1, which means what leads to minus 1 to the power 7, which is minus 1. Now the remainder cannot be negative. So what do? We actually add the divisor to it, and we get the remainder as 5. Now, hopefully, this allowed you to appreciate the concept of negative remainders a bit more. Can I solve this using the concept of positive remainders? Yes, Nishant, I can. You just have to calculate what's 5 to the power 7. That's all that you need to do. And then you have to divide that number by 6, and you're going to get to the same one. So now I think we are ready to solve the 700 or 750 level data sufficiency questions. But the core thing over here is the whole concept is still dividend is divisor times quotient plus remainder. We are just getting better at visualizing how to apply this concept. We're just getting better at we're getting more comfortable with this concept and more confident about it. And the more confident we get about it, the more belief we have in our ability, the easier it becomes to solve questions. Okay, so so sometimes negative remainders are very useful, all right, but make sure you apply the constraint that a remainder is always positive. So you add the divisor in the event that you get the remainder to be negative. So the positive remainder is negative remainder plus your divisor. Now we're going to go back to the 3 questions that we did, all right, and I'm going to ask you to attempt those questions again. So let's go over here. With this newfound knowledge that we have, let's attempt these questions again. And again, you guys know the drill. It's still solving. I'm going to reopen the poll, select still solving before I show question number 8 again. 3, 2, and 1. One more person, please. Can I get one more? All right, perfect. Here is the question. All right, get those answers in. Most of you are done. 5, 4, 3, 2, and 1. Let me end the poll. I'm going to broadcast the results. Now, earlier, about 37% of you got it right. Now, about 54% or 53.5% of you got it right. I want you, those of you who didn't get it right, I want you to tell me why did you not get it right, or where did you make a mistake. So let's see what's given. The question's asking, what is the remainder when a positive integer p is divided by a positive integer m, and m we know is greater than 1. So m is a positive integer, p is a positive integer, and we know m is greater than 1. All right, and so let's kind of go analyzing this. Okay, so let's analyze the question statement. What it tells us is to find the remainder when p is divided by m, and we know m is greater than 1. Let's analyze statement number 1. When you analyze statement number 1, statement number 1 says that p is equal to m plus 1 to the power 8. Okay, which means the remainder, when we find the remainder that p is divided by m, we get p by m is equal to m plus 1 to the power 8 divided by m. We need to find the remainder of this, which means, as we said earlier, we can simplify this to m plus 1 by m whole to the power 8. We have to find the remainder of that. The remainder of m plus 1 divided by m is nothing but 1. Why? Because m by m is the remainder is 0, and 1 by m the remainder is 1, and 1 to the power 8 is again 1. So we can be very certain that the remainder of this expression is 1. Statement 1 is sufficient. And then just look at this again. This is exactly what we've been doing in terms of pure numbers, right? Isn't that what we've been doing in terms of pure numbers? That's what we just did a few questions back. So statement 1 is what part do you want me to explain again, Vishesh? Why do we divide by m? Because we have to find the remainder when p is divided by m. That's why. Okay. So statement 1, why do we raise the power of m as 8? Because we are given over here that p is m plus 1 to the power 8. That is why. Okay. How m is included in the bracket? I would recommend, Kabir, to go back, look at the prior examples that we did, and you're going to find that we did exactly that. Okay. JFD says, would it work if R was 2 and the info was M is bigger than 1? JFD, you have to send the question to me to be very specific. But again, remember this. Data sufficiency questions are built around very specific constraints that will give you definitive answers. And in this case, it might not seem to you that you could get a definitive answer, but you are getting a definitive answer. So when you do this, you say, I'm left with, I know choice A could be correct or choice D could be correct. Choice A is statement A is enough. Choice D is each statement is enough. Now let's evaluate statement number 2. Statement number 2 says it gives you a value of M. Now when you independently evaluate statement number 2, does that tell you what's the remainder going to be when M is divided by when p is divided by m? No. Why? Because we don't know anything about p. in statement number 2. All right. Hence, statement number 2 is not enough. So the correct answer is choice A. All right. Just one second. I see a question. Okay. Someone said, I'm seeing in all these questions that we've solved, the powers don't matter. And I don't think the powers don't matter. It's just that the way you can simplify the expression, what happens is that the powers can be further simplified. And that's where the complexity that you think that a power would add is not the complexity that it actually adds. Now let's look at the next question, question number 9. And again, the expression will scare you. But if you apply the learnings, you're going to find that this question is fairly simple to solve. Let me look at the stats up front. And let's kind of go towards still solving. And again, some of you may not get this right away, but if you revise what we did early on, you're going to find doing this is very simple. Three, two, and 1. So here is your ninth question. Last 15 seconds. 3, 2, and 1. Let's end the poll and let's broadcast the results. So choice A is the correct answer over here, and but 38% of you got it right. I want you to look at my solution and tell me where you faltered. It's really, really important to understand where you're faltering, because every concept that's tested in this solution has been taught before. So this is a really important question with regards to making sure that you understand what you need to do. When you look at this original expression, what's the first thing that comes to mind? What's the first concept that you think you need to apply just to really get to the correct answer? Negative remainders, yes, negative remainders. 39 minus 1, why? Because 39 is divisible by 13. So let's kind of look at this over here. If you know that you have to apply the concept of negative remainders, then you should have solved this question. Okay. So even before we go into statement 1, we have to apply the concept of negative remainders, and just to make sure that we simplify and understand what's needed. What's been asked is we have to find the remainder when 38 to the power n square is divided by 13, and where we know that n is greater than 0. Okay, so we have to, so essentially what we can do is we can really figure out the remainder of 38 divided by 13 to the power n square, which, if you apply the concept of negative remainders, 38 can be written as 13 times 3 minus 1, which essentially, I don't want to write it down as this over here, which means that the remainder is going to be minus 1 to the power n square. How many of you were able to get to this over here? Let's reopen the poll. How many of you said, hey, the remainder is going to be minus 1 to the power n square? Now, this means two things. One, if n is odd, then your remainder is going to be 12. Why? Because because your remainder cannot be negative. So in that case, you're going to add 13 to it. If n is even, your remainder is going to be 1. So if n is odd, the remainder is going to be 12. And if n square is odd, the remainder is going to be 12. If n square is even, the remainder is going to be plus 1. How many of you were able to get to this point? Okay, now if you were able to get to minus 1 to the power n square, can you see that this simplification makes a lot of sense? Okay, if you were able to get to minus 1 to power n square, can you see that the simplification makes a lot more sense? Yes, it does, right? It just simplifies things a whole lot. So all you need to figure out is n odd or is n even? If you can figure it out, you have your answer. There is really no math required beyond this point. Okay, now let's kind of do statement 1. Okay, let's analyze statement 1. Statement 1 says n is equal to 4k plus 0. What does statement 1 say? N leaves no remainder when divided by 4, which means n is equal to 4k, which means n is even. So if n is even, we know that the remainder is plus 1. So statement 1 is sufficient, right? Can everyone see that? Once we've simplified the original expression, we can really say statement 1 is sufficient. Now let's look at statement 2. Statement 2 says, so after this we are left with choices A or D. Statement 2 says square root of n is only divisible by 1 in itself. In other words, what this is saying is that n is a square of a prime number. Okay, if square root of 1 is only divisible by 1 in itself, which means square root of 1 is of n is a prime number, which means n is a square of a prime number. Or in other words, it means n could either be 2 square or 3 square or 5 square or 7 square. Now, a square of a prime number can be even or a square of a prime number can be odd. So we don't know whether n is even or n is odd. Hence, statement 2 is not sufficient, which means my correct answer again is choice A. Now, there could be many places where you could have slipped on this one, but what is that one place where you faltered on this particular question? What is that one place? Original statement analysis is where a good chunk of you faltered. You couldn't figure out that you had to simplify it. Some of you did not forgot that 2 square can be even. And again, you can really see this. If you got to that level of analysis, but you forgot that a square of a prime number can also be even because 2 is also a prime number, you did 95% of the effort right. And because of that 5%, you got this wrong. Okay. All right. Forgot about 2. But again, that's kind of where this feedback's really important. Now, some of you did the cyclicity rule. Again, I don't recommend that you do that. It's a bit more sophisticated. All right, let's kind of go towards the last question for the day. Let's select still solving. Three, two, and 1. Here is the last question for the day. All right, let's get those answers in. We have about 80% of you that who are almost done. Three, two, and one. So in this case, choices A, B, and D are really popular. Choice D is about 45% of you. Choices A and B are the other, but another 38% or so. So, I mean, if I combine these three choices, it's pretty much everyone barring the 6% who chose choice C, which I think you were playing safe. Now, those of you who've chosen choice A or B, I want you to tell me why is it that you chose choice A or choice B, and where did you falter? So this question is very similar to the prior question where we have to do a certain simplification before and draw inferences before we actually move on to analyzing each statement. All right. Um, so the question asks, what's the remainder when 4m is divided by 16, where m is a positive integer that is greater than 1? So essentially, if you analyze the question statement, you have to figure out the remainder of 4m by 16, where m is greater than 0. Or in other words, if you really write this down in terms of uh, dividend is equal to divisor times quotient plus remainder, you can really say 4m can be written as 16q plus r, where you have a positive quotient and the remainder has to be, of course, less than 16. Why? Because we are dividing everything by 16. All right, so let's analyze statement 1. If we analyze statement 1, what we can really see is that m can be written as 32 to the power 30. Statement 1 says m leaves a remainder of 4 when divided by 32 to the power 32. It's like a crazy looking number. But in general, what it means is that m can be written as 32 to the power 32 plus 4. And when you do this, you can really say, hey, but we have to figure out what's the deal with 4m, okay, and what remainder does it leave when you divide this by 16. Okay. So far, everyone's with me? Let me just clear all answers. So far, you guys are with me? All right. So you multiply both sides by 4, and then this expression leads to 4 times 32 times 32 into k plus 4. That's multiplied by 4. Essentially, as we simplify this, you multiply 4 with both the terms. This is your first term. This is your second term. And when you look at these two terms, you kind of realize both these terms are actually divisible by 16. And hence, the remainder is 0. Okay, the remainder is 0. So we know when 4m is divided by 16, the remainder is 0. So we know what the remainder is. So statement 1 is sufficient. Now, how many of you were able to get to this, that statement 1 is sufficient? Well, I can see at least 44 plus 19 or so. So about 63% of you were able to get to this. For those of you who weren't able to get to this, why? Where did you falter? For those of you who were not able to get to this, what made you falter? Why did you or where did you falter? We're still using the same equation. Dividend is equal to divisor times quotient plus remainder. Okay, thought the remainder could be found. That's okay too. Sometimes you kind of feel the numbers, and that's okay. Now, let's look at statement 2, whether statement 2 is sufficient, because now we have choices as A or D. All right. Statement 2 says that m cube is divisible by 16. Now, we have to figure out what's the remainder when 4m is divided by 4 by 16. And we know that m cube is divisible by 16. So we express m as 2 to the power a multiplied by prime p1 times p2, p1 to the power b times p2 to the power c. So where p1 and p2 are prime numbers. Okay. Why do we do that? Why? Because we know that m is divisible by 16, which means it is divisible by 2 to the power 4, or a is a multiple of 4. Sorry, 3a is a multiple of 4. My bad. So you cube both sides, you actually get this, and then you say, hey, because this is divisible by 16, which means 2 to the power 4, then 3a has to be greater than or equal to 4, which means a has to be greater than or equal to 4 by 3, or at a bare minimum, a is equal to 2. Now, if this is too complex for you, what you really say is m cube has to be divisible by 2 to the power 4, which at a bare minimum means that m square has to be divisible by 2 to the power 4, or m has to be divisible by 4. You can also get that inference, which means 4m is also divisible by 16. That's another way to look at this as well. Essentially, what you would get is that m is 2 square times something, which means 4m is 4 times 2 square times something, or 4m is 16 times something, which means the remainder when you divide 4m by 16 is 0. Okay, which means statement 2 is sufficient as well, which means choice D is your correct answer, where either statement is sufficient. But 45% of you got it right. I think another 35, 37, 38% of you were on the verge of getting it right, but faltered somewhere. Where did you guys falter? The other 37, 38% who chose either choices A or B. Because if you chose choice A, statement 2 is where you faltered in a big manner. All right.